In the grand expanse of the universe, a small and incredible entity known as planet Earth revolves steadily. Here, the laws of physics dictate the evolution of life. Each of these universes is assumed to have its own set of laws governing its composition. Although the physical constants in these universes might be extremely different from our own, that does not render their existence any less plausible. They exist, hidden from ours by their own dimensions. In this documentary, we dive into the depths of these mysterious theories, as we explore the multiverse and hidden dimensions. The concept of a multiverse is not a recent innovation. Ancient philosophers like Democritus envisaged a cosmos where infinite universes existed, each differing from the other. However, the theory truly gained momentum in the 20th century, with the introduction of quantum mechanics, and the groundbreaking work of scientists like Hugh Everett. Hugh Everett presented the concept of the parallel universe, asserting that for each observable phenomenon, there are several universal responses. He proposed that instead of these alternatives However, before we delve deeper into the intricacies of the multiverse, let's take a brief look at quantum mechanics, a theory in physics that describes nature at the smallest scale of energy levels, including atoms and subatomic particles. This is the basic structure that, to better understand this, imagine flipping a coin. The established paradigm suggests two possible outcomes. While visualizing parallel universes can be daunting, physicists have postulated certain types of multiverses in an attempt to simplify understanding. Max Tegmark, a cosmologist, proposed an influential classification that breaks down the multiverse into 4 levels. Each level offering a subtle, yet fundamentally different. The simplest of these, level 1, stems from spatial extension. Tegmark presupposes the universe to be infinite in size and thus, containing numerous Hubble volumes, each identical to our observable universe. And within these volumes could be realities nearly identical, yet subtly different from ours. The level 2 multiverse goes a bit farther by incorporating the concept of eternal inflation, introduced by physics. Level 3 multiverse, the one closest to Hugh Everett's original proposal, is grounded in quantum mechanics. It's postulated that every possible outcome of an event creates a new universe. The result is a constant spray of branching universes and a mind-boggling array of alternate realities. Finally, the level 4 multiverse is the most abstract one. It proposes mathematical universes truly unconnected to ours. Every definable mathematical structure can be its own separate universe. This brings us to the question of dimensions. Understanding dimensions is critical because they construct the reality we perceive. Currently, we experience life in 3 spatial dimensions and 1 of time, but theoretical physicists postulate there may be more beyond our perception. Albert Einstein, in his general theory of relativity, proposed a 4-dimensional space-time continuum, suggesting 3D space and time are interrelated entities. However, later theoretical physics models like superstring theory and M-theory propose the existence of multiple dimensions, far more than we have ever perceived. Superstring theory, a candidate for a theory of everything, assumes the existence of 10 dimensions, 3 space, 1 time, and 6 compactified dimensions. As for M-theory, it corresponds to 11-dimensional space, the additional dimension acting as a bridge between different universes. At the heart of string theory lies the concept that fundamental particles are not point-like, but rather, one-dimensional strings that vibrate at certain frequencies. Each modes of vibration corresponds to a different particle, thus unifying all known particles and forces in one framework. So, how are scientists planning to validate these theories about other universes and dimensions? Unfortunately, direct empirical evidence. One of these signs might be the disappearance of high-energy particles or cosmic rays into hidden dimensions, creating a decrease in the expected energy output. Another sign could be the effects of higher-dimensional black holes on our own 4-dimensional. Here on Earth, physicists at the CERN Particle Physics Laboratory are already conducting experiments to test for extra dimensions, using their monster particle accelerator, the Large Hadron Collider. If successful, they can verify theories predating our current model of physics and transform our understanding of the universe. The theories surrounding the multiverse and hidden dimensions are undoubtedly complex and surreal. So while we ponder the possibilities of the multiverse and the unperceived dimensions, we must bear in mind that upending traditional knowledge and breaching the boundaries of the known are part and parcel of the human quest for understanding. Theories of the multiverse and hidden dimensions remind us of the boundless potential for discovery. Who knows what we will find when we dare to venture? We live in exciting times. Every day, innovative minds are working diligently, coming closer to answering some of life's most profound questions. We may not have concrete proof of the multiverse or hidden dimensions, now. But with the spark of human curiosity and the power of unyielding determination, we inch closer, and the intricacies of the multiverse theory and the concept of hidden dimensions reminds us that reality. As we peer deeper into the cosmos, straining our technological eyes to see further than we ever have before, we're confronted more and more with sights and phenomena our current understanding of physics can't explain. Are these signs of other dimensions and universes, waiting to be discovered? Despite the complexity and challenge presented by the multiverse theory and hidden dimensions, they also represent enormous potential for the future of physics and our understanding of everything. And who knows? Maybe someday, we will uncover these hidden dimensions and the multiverse will not be a theory, but a proven reality. Such potential discoveries are not products of individual endeavor but collective human achievement. They are forged in the crucible of collaboration, where the brightest minds come together to chip away at the enigma, one calculation at a time. Philosopher Pierre Teilhard de Chardin once said, "We are not human beings having a spiritual experience. We are spiritual beings having a human experience." As we reach the end of this journey through the multiverse theory and hidden dimensions, let's remind ourselves that every scientific theory, every universal law, every shred of knowledge we possess, originally sparked from human curiosity. Curiosity that dared to look upwards at the stars and wonder. Maybe we are alone in our universe, maybe there are other dimensions, or maybe there's an infinite array of universes, each with its own sets of laws and physical properties. The mysteries of the multiverse and hidden dimensions continue to captivate our imagination, challenging us to become more than passive observers in this grand cosmic dance. As we stare into the infinite expanse of the